So let's talk about some hazards and concerns that come up with groundwater. One of the big concerns with groundwater is that over time we deplete our groundwater supply and then we have less left to use. So essentially this happens whenever groundwater is pumped faster than it is recharged or reintroduced from rainwater into the system. Sometimes we can have very local depletion of groundwater, think like as big as someone's tax lot or parcel. Other times we can have depletion over an entire region. And when this sort of thing happens, when we're removing this much groundwater from the ground, we can also have subsidence or lowering of the land in that area. So here's an example here where we're starting, the aquifer is shown in blue here. This the area above that would be the unsaturated zone that we would not be able to pump from. And this person who has owned a farm here has dug 3 wells into the aquifer below the water table, and they're actively pumping this first well. And I know they're actively pumping this first well because there's a little downward tick in there. We call that a cone of depression. It's just essentially where the water is being pumped out of the ground. We would locally lower the water table just in that little area here, and they might just be using this water for their own for their own needs, for their animals, and for their house here. But at a future time, they decide to use this middle well in order to pump it at a higher rate in order to irrigate this field. So they get that all set up and they start pumping and they grow a great crop there. But what we can see now is that because so much more volume of water is being pumped out of the ground, there is a much bigger cone of depression now associated with this central well, which is being pumped so much. And now this cone of depression is actually causing 2 of the other wells to go dry because they're no longer in the saturated zone or below the water table. They're actually in the unsaturated zone above, and there's just no way to pump water out of the ground if you're in the unsaturated zone. That could be on a farm type level, but overall there are so many farms and so many aquifers that historically have been very good and reliable for people that it can become a regional issue. This is one of the most famous aquifers in the world, and especially the United States. It's called the Ogallala Aquifer. And as we can see in some places, parts of it are almost as big as the entire state of Nebraska. It's divided into 3 parts, a northern, a central, and a southern part. And of course, some of these areas here, such as Oklahoma and Texas, are drier than other areas and might be relying on this aquifer more. But what we can see is that over time, here's the Ogallala Aquifer, once again outlined here, and much of that is going down at a steady rate as far as how much groundwater is being stored there. The water table is going down by about 2.5 centimeters per year, which is about 1 inch a year. Not a lot, but it's such a big and regional aquifer that it's really impacting a lot of different wells in that area and can have a big impact on farms or industries that are using groundwater in that area. And we can also see that's not unique to the Ogallala Aquifer. There's plenty of other aquifers and groundwater sources throughout the United States that are also being depleted, especially in the South where there's been more growth of industry and more people moving. And one of these areas that's especially impacted is the Central Valley Aquifer of California. This is sometimes called the Great Valley, and it includes the Sacramento and San Joaquin Valley. And not only is the groundwater being pumped out of the ground, this is an area that has a lot of agriculture going on in it, especially high-end fruits, vegetables, and nuts. That sort of thing is typically grown in this area here. But they need water to do all that, and a lot of water has been pumped out of the ground here. And so much water has been pumped out of the ground that actually the land is subsiding here. And as we can see, this shows the San Joaquin Valley here, highlighted in orange over here. And in certain areas of the central San Joaquin Valley, it's gone down by about 8 meters or about 25 feet in certain areas there that we could outline on a map. And this once again shows the San Joaquin Valley. This person, and this has been going on for years, this person here is standing in in 1977, where the ground level is here. In 1925, the ground level used to be all the way up here, and slowly over time, the ground itself has been subsiding in this area here. Not like an earthquake, it's more like a balloon being deflated because everything is going down at about the same rate. But this subsidence can be a big issue because it can cause local movement of the earth, and it can also cause things like changes in drainages, and a lot of other issues can result from this land subsidence. And that's all due to groundwater being drawn out of the ground, and the ground just no longer having that volume of material underneath it that was previously holding it up, and the ground itself sinking if we remove enough groundwater from it.